history.
Thank you. So I know I probably look like I'm going to try to sell you blockchain AI in the cloud. I'm not. I'm one of you guys. I'm just differently dressed. Now, I'm going to try to speak about... I used to give this talk the other way around. I used to say, like, look, this is what we need. Like, we build this up, this technology, and then at the end, look, now you can do fantastic things. And no one was really following. So this time I'm going to give the talk backwards. Actually, let me start the recording. So first I'm going to say, this is what I want, and then we'll see how we get there. And
then
start
from profit, then
yes.
the question mark.
Exactly.
And then
precisely. So I'm going to try to show you what I want, and then convince you that you also want this, and then I can show you how to do it. So we'll see what happens. This is all going to be Haskell code and talking. So if you don't know about Haskell or you don't know what it says here, you can just ask me and I'll tell you this is the gist of it. You don't need to understand what it is. All right? It's mostly for show, right? Most of the stuff is not going to compile because it has stuff like these placeholders and too much white space. Anyway.
So Haskell doesn't look like that. You can just say.
All right. So I'm really annoyed by the state of quality of software, and I want to do it better. Now, I've tried a lot of things over the last 5 years, and all of the things that don't work is telling people your code is wrong, fix it. That doesn't work. What also doesn't work is saying, I have this proof assistant, and you can make sure that everything works. Now, use it for 12 hours and see if you can prove something. That also doesn't work. People don't care about quality if it takes time to do it. So, new goal, we're going to try to make it easy to make good software. So we're not going to make it sound or fast, but we're going to make it easy. That's the new goal. So I'll show you what I mean by that. Is this readable, by the way? Can everyone vaguely read what this is? All right, so suppose you have some tag data type. Can I point at this? No, okay. You have some tag data type. The tag is a name and it has a value. They're both text. And there are some invariants on this tag, so there can be no white space in the name and there can be no new lines in the value. Fine. Then you have some function that does something useful. Now, in order to check that this function works, you have to come up with what does it do, why does it do that, what do I want it to do, and then write some complicated long testing thing, right? I want something easy and cheap there, right? So it should be short. Now, with the tools I'm going to show you, you can do something like this, if the pointer works.
Maybe it works on you.
Something like this, voila. So you fill in these few lines, you explain these invariants in code, and you can write a single line test suite. You don't have to understand what this means yet, I'll show you later, but this is what you can do, right? Other thing I want. I have my type, it has a boolean and it has a double, you can convert it to JSON and back, and I want something cheap to test that this works. Right? It doesn't need to be performant, I don't care, it just needs to work and it needs to be really easy to check that it works. So you can do this, so 4 extra lines and now it works, or you test that it works, that's the idea. So you have these few lines, that's all the code you need by the way, and then you have the single line test suite and then it checks that JSON works for you. Something else I want. I'm writing my own monad here that happens to be maybe with another name, but I didn't realize that. So I write my instances, and now I want to check that this works. So all the laws need to hold. That's the point. So you can do something like this. 3 extra lines for tests, and suddenly you have all your laws tested. That's the idea. Something else I want. Lenses. They need to work. They have laws as well. We need to make sure that these laws hold. So I have my lens here. I want something cheap that tests that these laws hold. When I say cheap, by the way, I don't mean it uses few CPU instructions. It needs to be few keystrokes. It needs to be short to write. I need to be able to do it in 1 minute. So you can do something like this. 3 extra lines, 1 extra line for your test suite, bam, lens laws hold. That's the idea. Okay, this is the part where I should have convinced you that you want this as well.
Do you follow?
So what do you need in order to make something like this happen? Cheap testing requires that we use property tests, because then you get 100 tests for the price of 2. It's a little bit extra work to write a property test and a unit test, but they're way more useful in terms of how much stuff you test. Now, the problem with property testing is that you need generators for the input data, and you need shrinking to make sure that if anything goes wrong, that the input is shrunk a bit so you can see what went wrong. And these properties are really annoying to write, so it would be nice if we could have these properties for cheap, right? So that's what we need to get this done. So to make cheap generators, I'm going to start here because it leads on to the right next parts afterwards. So how do we make cheap generators? In QuickCheck, we have this arbitrary type class. Arbitrary allows you to define how you generate a certain value of your data type. Now the problem is, no one knows how to do that. And you have to do it manually. There are no semantics for it. So suppose you have some sort of invariant on your data type, what do? Do you generate any possible value or only the ones that are valid? Or do you have to, so if you only generate the valid ones, then you can never test your code with invalid values. If you only generate unchecked, so any value, then you may want to also test that your code only needs to work for the valid cases in some parts of your code. So it would be ideal if you can also write cheap generators for that. So then you would actually have to have two separate generators for each, but then you lose the composability that a type class gives you. So you can no longer write something like, if I can generate this thing, then this function is associative. You can no longer do that. If you have separate value level generators for each, it's not as composable anymore. So we don't want to give up the type class approach like we do in Hedgehog, but we still want to make sure that the generators that we have acknowledge that there may be invariants on your data type. Now, for those of you who think that these invariants are not very natural, it's just this, it happens to be this weird thing that we need, it's not actually true. Invariants are very natural. An invariant on a data type is exactly like a type. A type is just constraining the amount of values that your thing can have at compile time. And now these invariants on your data type will further constrain the values that your value can be at runtime. So they're going to be extra invariants, so a smaller subset of a type really that you don't really check at compile time. That's the only difference. So these invariants are as natural as just types. That's what I want to understand here. So why are these generators not cheap to write? The problem with QuickCheck is that there are no semantics. That's the wrong button. There are no semantics for arbitrary, which means you cannot generate them. You have to write them yourself, and no one knows how to do that. There are people who know how to do that. I don't. Just for clarity, I don't want to be too arrogant about that. So I don't know how to write those. That's a problem for me. Right. So how could we have cheap generators? For example, if we generate all possible values that can exist, then we can generate these generators. Exception. We can generate the implementation of a generator if we can have the semantics that you must be able to generate all possible values. Because then you can use generic programming to make this happen. So we make this type class called genUnchecked, which has the semantics that you generate all possible values. And then you also have shrinkUnchecked, which shrinks all possible values in a somewhat sensible way that can be pre-programmed. And then you get both the generators and the shrinking for free, given these semantics. Right? So now we haven't talked about values with invariance yet, but this is one step to get there. All possible values, free generators, free shrinking. That's step one. Everyone still with me? Any questions yet? Okay. I'm being very excited.
So it's like almost the same like normal arbitrary instance, right?
Yes. But the difference is, say you have some sort of new type wrapper over prime. It's my next slide. If you write genUnchecked for this, it will generate prime 6, which is not a prime, so that's problematic. That's the only difference with arbitrary. With arbitrary, you could reason that you actually wouldn't want to generate prime 6.
Right. So if you have a new type, you probably make the generator that just filters it somehow.
I'll get to that. So genUnchecked doesn't do that on purpose. Now, suppose you have some sort of a new type wrapper over integers that represents primes. Now, you want to be, well, I wanted to be able to encode what it means for this thing to be valid. So we made a type class Validity. It checks whether a value is valid. So it checks whether the prime is in fact prime. That's all that this does. It returns a boolean. Now the problem we quickly found out is that suppose you have this, if you have a single prime, 6, you can say, oh, that's false. And we can see, oh yeah, 6 is not prime, that's fine. If I have a list of 100 primes and it goes, no, that's not valid, then you're kind of stuck and you don't know where the non-prime is, right? So we changed this type class a bit to return a validation object, which just tells you why something is valid. And then you can say something, you can ask for the validation of this list of primes, and it will tell you, no, this is not a valid list of primes because at index number 3 there is a violation of an invariant, this thing is not prime. And you know exactly where the problem is. That's useful by itself, but it will be more useful once we combine it with these generators. This is a separate package as well if you want to use that. Now, cheap generators for values with invariance. Once we have the unchecked generator, which can be generated, now we have a default implementation which generates an unchecked value and checks if it's valid. If it's valid, you let it through. If it's not valid, you throw it away and try again. This is an implementation of a valid generator for any type generated by default implementation. So you don't have to write any more than just instance gen valid. It also gives you shrinking for free because you just shrink unchecked values and let only the values through that are valid. And then you get free shrinking even for values with an invariant. Now, to do this efficiently is an open research question, so I'm happy with this. So we have a default implementation that makes...
One question about semantics. Because assuming that we can shrink unchecked in one step to something that is not valid, does shrink valid have a requirement to generate all subfragments or not? Is there an additional condition on that we don't know?
As far as I'm concerned at the moment, the semantics for shrink valid is only that everything that it returns is valid. Now, you can argue about what shrinking should be doing, but all I care about here is that whatever you return is still valid. And that's important for reasons that are beyond the scope of this talk, but I'd be happy to talk about it afterwards.
So there is no semantics attached with shrink that would require that it returns, for example, all fragments of...
No. The reason is shrinking is for humans. Shrinking only needs to make something smaller so that it's easier to figure out why your test failed. Now, what it means for something to be easier for humans to figure out is very hard to put into semantics. So that's why there are no other semantics to this. The only real problem with shrinking is that your shrinker has to obey the same invariance as your generator. Otherwise, you get very weird error messages.
Okay.
All right? Now, once we have these three things, so the validity type class, the gen unchecked type class, and the gen valid type class, by the way, there's also gen invalid, but that's beside the point, you can write very general property combinators, and this is how you get cheap properties. So you can say something like, whenever I pass in a value to this function that returns a maybe, when you pass in something invalid, it will fail. That's now a property combinator. So you use this function, you supply your own function, and you get a test property that will test this for you. Same thing with valid if succeeds. So that says whenever this thing succeeds, the result is valid. Succeeds on valid says that whenever you pass in something valid, it will succeed. So these are very general properties that you can now write.
What's the difference once again between a valid succeeds?
So valid if succeeds says that when it succeeds, the result is valid.
Okay.
And succeeds on valid says that whenever you pass in something valid, it will succeed. You can see it by the conditions, the constraints. Now, you can also write much more useful things like these two functions are equivalent as long as you pass in valid values. Or this function is associative as long as you pass in valid values. This is, for example, now I have to say something non-stupid. You get in trouble with invalid doubles, like not a number and infinity. Most of the mathematical properties fall apart completely. For example, even reflexivity of equality falls apart because of not a number, unless you have the constraint that you only pass in valid doubles, and suddenly it works. That's why this is so important. Oops. And then there's another one, inverse functions if succeeds. So this is a bit complicated, but the idea is that two functions, they can both fail in possibly different ways. Whenever they don't fail, they are inverse functions. It's a very general property. You can now get it for cheap because it's already defined for you. More cheap properties, and this goes one step further. These are test suite combinators. I write my own ORT instance. I want to be able to test that it makes sense. Should be easy because it's something I can predefine. So we wrote this thing, ORT spec. You pass in a type. I'll explain how that works in a moment. And you get a test suite. and then you can have it constrained to only valid values. So then the output looks like this. You say ord spec, pass in the type integer, and you get 14 properties that check whether ordering makes sense for cheap. So that's 1,400 tests in one line. Now, this type application is a bit annoying. So you pass in the type integer. The way that works is we have this ambiguous type for all A. So we say for any A, this is a test suite, and the A is never used in the type of the test suite. So you need some language extensions to make that work. But then you can use type applications, and you can apply the type with @int. That's all you need to do. You can do the same thing for higher kinded types. Does that make sense? Higher kinded. So type constructors. That's the word. I can test that my thing is a functor by just saying functor spec @list. And now I have all the functor laws for a list, all tested for you. This is one line, all the laws are tested. That's the idea. I'm going through this very quickly, aren't I? Anyway. Next up, you can do the same thing for JSON instances. You can have a single line that checks whether your JSON instances make sense. So you can say JSON spec @type, and you check that encoding never fails, so you never get an error while encoding. You check that whenever you encode something and you decode something, it succeeds, and you get the same thing back. So I doubt that most of you have written this kind of test for every single JSON instance that you've ever written, just because it's so annoying to do that every time, but now it's cheap. And the thing is, you can even write parse JSON equals undefined, put this in your test suite, and then
JSON and ORD are usually derived, and you don't need to test them, right?
I don't derive JSON. Usually I use, well, you can use template Haskell, that's true. Usually I write them myself because I don't like template Haskell. That's right. For ORD instances, you're also right. You don't have to test derived ORD instances per se. But if I write my own ones, I want to make sure that they make sense.
But actually, this doesn't really test any business value, right?
That's true.
You're testing if it's like encoded and decoded, but not if it's a valid JSON from business perspective.
Yes, that's right. So I said cheap. I didn't say useful.
Okay.
We're using Haskell, so we.
Okay, yeah, business. Sorry, Haskell.
You know what I meant?
Yeah,
but you make your data to make sense, and if it makes sense, then encode it to some JSONs.
And this has been a problem more often than I would like to admit, which is why I want these tests to actually be there before it becomes a problem. And these tests have failed more than once in my actual business logic, where it could have caused a business problem, even if it's not dealing with business logic per se. That's why this is important to me.
The other argument is that if you use event sourcing, then you put all your business logic into events and state machines that handle it. This will check that some properties are valid, right?
Okay, but my point was, okay, you are developing an API for, I don't know, mobile, for mobile applications, and they require you to have this, and this field, and return this, and this.
Yeah.
And such test does not test if your JSON has a valid format.
But your problem is solved by the type system in Haskell, because usually we describe your API as a types, so they can return only those types which are...
Yes, it is, and I agree, but, well...
So if
There's
you
no
mean the
prepackaged
interaction
business value yet.
between non-Haskell code and Haskell code, no, probably because this is checks inside Haskell code that you have valid value, right? But if you add types for these non-Haskell values that you handle, right, then that's it, right? And these types you can generate automatically from Swagger. So it should be outside of scope because it's handled by somebody else.
I mean, I've done this before. I don't want to claim to be an expert on it, so I'm not getting involved into that. I just want if I write some JSON serialization, it needs to work, and I want something that checks that it works because I'm stupid. Next step, you can do the same thing for lenses. One line, 5 tests for your lens laws, and then also some extra stuff to make sure that you get valid results. So, single line test suite, 500 a test. Next step, how much does it cost to do this? 7 lines. You write a generic instance, which is derived. You need a language extension for that. This single line generates the implementation of the generators for unchecked values. That's it. I'm not omitting anything here. A single line to get you the generators for unchecked values. A single line to implement validity if you have no other constraints, then all the subparts are valid. And then a single line to generate the implementation of the generators for valid values. So that's 3 lines of instances and this generic instance. That's
of course, it helps much more if you have more in the validity, right? Like you have a
yes.
binary tree and you have actual invariance.
Yes, and all of the dependencies that I use already have these instances provided in packages, so you just add them to your dependencies and suddenly you have these validity instances. So most of that annoying work has been done already. These are all the test suite combinators that were there at the time I wrote this presentation. So there's GenValidity HBEC, which contains all of these property combinators and test suite combinators. Then there's the one for ASIN, which does the JSON serialization testing. The same thing for binary and serial for binary. Hashable makes sure that the laws of the hashing thing works. And optics is for lenses for now. Just lenses for now because I haven't done the other ones. So that's the idea. And that's actually already the end of the presentation because I didn't have much more, but I have plenty of time for questions. So, and I can also demo some stuff if you'd like. So that's how I want to make testing cheaper. Testing is usually fine. People are not bad at testing, but they don't like to do it. That's the problem. So we make it cheaper so that they'll be more likely to actually do it, and that's how I hope to get a bit better software in the end. Make sense? Cool. Any questions?
I think it's great, but did you like make a statistics on what are the classes that are most frequently used and how many of them you already cover? Because, you know, I strongly suspect that like 99% of classes that we use, unless we define something in our own code, are those in the standard library, but it's not confirmed.
Yeah.
Because there are things like, I don't know, servant, binary as in serial, and all the other serializes that creep up everywhere too.
Yeah. And so I break code for a living, and it's usually the easiest to break code by using anything which is called section category theory, I think. So anything that can fail one way but is go easy the other way. It's usually when it can fail one way, that's exactly how we can break it. So that's usually serial, JSON, binary, that kind of stuff is usually how we can break things. Which is exactly why we have these standard things. I have no idea how much I've already covered, but I haven't written many more of these lately, and I use it in most of the stuff I do. So the only thing I added lately was that if you show something and then you read it, then you get the original. Which not always hold, it doesn't always hold, but it should hold in my opinion. Long story, I don't want to debate that. But yeah, that's the idea.
How many of these standard classes do you have covered? Like num or fractional?
Not num, not fractional, definitely not, because those are poison. But I can show you what I do have.
How they are poison?
So the problem with num is that you need from integral in num, which doesn't make sense. And if you just want literal numbers, then you need to implement num, but just because you have literal numbers doesn't mean you can add them or multiply them. So they're weirdly coupled in ways that I don't like.
So you mean that the classes are not split in proper, like monad return problem, right? Where return and bind was in a single class now.
For example, yeah. So these are the ones I have already. So these are the validity instances. And then there are the GenValidity instances. Now if I go into Gen...
Does it mean that we can define our time type and remove the problems that we have with all the other time packages now, because it will be automatically tested?
So here are the type classes that I've already covered. So I have got applicative, arbitrary, equal, functor, these gen-relative validity, a bit of a side thing, monad, monoid, ord, show, shrinking. Yeah, so these are all already covered just from base. And then there is... Sure. It's not really different than exactly what you'd expect. So here's the ord one, for example. Yeah, I had to make sure that HLint ignores some stuff, because when it says use greater than instead of not smaller than or equal to, that's exactly what I'm trying to test, so I don't want to put this. Anyway, so it's mostly string juggling to make sure that the names of the types are nice in the output. And then you just describe exactly those tests. And I use the property combinators that I defined somewhere else. And I'll show you what I defined there. That's in GenValidity property. So for example, in relations, which is mostly what I'll be testing in ORD, you have anti-reflexivity. Voila. And that's your property combinator. And they're also tested in doc tests, which is quite nice. There we go. So if I now do stack test GenValidity HPEC test, you get some nice output. So this is what the output of those property combinators and the test suite combinators look like. So for example, here I'm testing some show instances. Here I'm testing some ORD instances, monoids, monads, some generators, functors, etc., etc. So a lot of this is already covered, and then there are also the async binary serial hashable and optics that I talked to you about. So in the case of optics, for example, I've used this one lately. We want to make sure that the lens laws hold. Where are they? Here. Exactly the lens laws. And they're all tested for you, so you don't have to rewrite those tests every time. That's the idea. Make sense? Any more questions?
So you break code for a living, that's what you said?
Yes.
So you're a tester or somewhere?
Let me rephrase that. I complain about code for a living. In my day job, I work at FP Complete, and I work on the Cardano code audit, project audit. So I look into other people's code and then see whether we can break it.
Great.
Yeah, I find generation with invariance impractical, because usually when you have a structure, some kind of real-world structure, the valid subset is so small compared to the space that, like, the only thing you generally keep when you try to find a valid value.
Yes, so that's exactly, that's a great point. So that's exactly why this is just a default implementation. So in GenValidity, there we go. GenValid has a default implementation that just checks something unchecked and then passes it through if it's valid, right? But you can just override this with something faster. And that's exactly what we do for a lot of these. So I've always made sure that if you don't touch it, it still works, but it may be slower. If you want it faster, you can touch it and you can make it faster, but then it's up to you to make sure that it still works. That's the idea. So for example, if you go to GenValidity...
But it's not easy then, right? Is it?
To make it faster.
I mean, like,
depends.
to generate the real world valid values is not easy. Sometimes I would attempt it and then I'll give up because it's just so hard.
Depends on the real world values, I guess. So here is a nice example. For maps, internally they're quite complicated, they need to be balanced nicely, etc. So the unchecked instance really makes unchecked maps, and then the valid instance just says make a map from a list. Right? So this will give you, this is a lot faster than just making unchecked ones and seeing if they're balanced. And you can just override it to make your own implementation, as long as what you generate is still valid, and as long as what you generate is all possible values that could be valid.
Of course, what you would like in this case is to check that you can generate all the valid instances this way, right?
Yes.
Or at least most, because otherwise that means that you are not testing all invalid instances. Right?
Yes, and I have found no solution for this. I mean, checking whether your generator will eventually generate a certain value, I don't even think that's decidable.
So, yes and no. There is hope in the kind of finite description length. So if you say that you have programs of finite length of say 10 combinators, then you can say that we don't really know what these programs do, but they can be only that complex as to distinguish these kind of values. But I don't think we really have an automatic version of this working for Haskell yet.
Yeah,
I don't even know about Cork. Right?
no idea.
So that's, I think, what rewriting people try to do. So basically constrain our program complexity and then say, because they are not too complex, then we can only distinguish certain things. Which means that we need to check finite amount of values before we know that it's valid or not.
Cool. No idea how that would work, but it sounds promising.
It basically means that you have so many, say, cases. You have programs with at most one case expression, right? Or at most two case expressions.
Programs as well?
Oh?
Does it work for recursive programs as well?
That's the point.
Yeah.
Because you limit amount of number of states that you have in the computation of the program, right?
Yeah. I mean, if it's recursive, then not really, right? Because you can have an infinite number of outputs.
But not internal states, right?
Yes. I mean, and if it generates an infinite list,
No,
you have an infinite number of states.
It will not work if you have a kind of infinite polymorphic recursion, but if it's monomorphic, then you have finite amount.
Yes.
For polymorphic recursion, I'm not sure because there is no proof, I think, for monomorphic. Yeah, sorry.
Any more questions?
Yes. There are these guys, I think. Edward has this idea that you use something like concolic testing. So you check this validity of instances, and it appears valid, but you want to check more complex traces, for example, of programs, right?
Okay.
Like those that you get from event sourcing.
Okay.
Do you have any heuristics to bias generation of these values?
Can you explain this question?
So when you do
traces.
when you break your program for a link, right? You are interested in breaking the program, and then you can, for example, compare the coverage of traces with your generator of inputs, right?
Sure.
Is there any way of...
I would love for programs to be good enough so that this would actually be a real problem.
Okay, that's fair. That's fair argument.
So usually when we break things, it's for way stupider reasons than our generators aren't good enough to actually catch all the cases that could break. Usually it's something like the password is password, of that level of stupidity. So when we actually get to a point where our generators aren't good enough to catch the cases that break our program is an actual problem, I'll be very happy. Until then, I'll see if I can work on it in my spare time, but not not for work.
Maybe this might be quite a stupid question, because you have already instances for monads, applicative functors, and stuff like this. How often do you write your own monad, functor, applicative?
Oh, not very much at all.
Okay.
But
it was just fun to write.
I mean, it's one of these examples that are very cool in presentations, and people think, oh, I need to use it because it has this thing for functors, and then that's really not what it's useful for, but it's still something that can convince people. It's fun to write.
On the other hand, I can imagine people starting writing the applicative or monad instances because they are easy to check, right? Because that means you get some tests for free.
Yeah.
And a lot of people write monad instances just instead of composing transformers because they think they will do it somehow better. Rio example, logic T.
No idea.
Yeah, these are the monads that actually do something that transformer stack of reader and logger monad or something like this would also work, right? But
I often start with my own implementation, but then, after, this is how it's worked, delete them and drag them. But, just to get it properly in my head, I write my own, like if it works, and then I say, okay, let's delete it.
So that's exactly what happened to me as well, right? When I showed you the example, I just implemented maybe and I didn't realize until afterwards. It's exactly the same situation. And then, if I know I'm going to be writing a functor, I'd like to put undefined there and write the test and then shotgun it until it is no longer read. So that's mostly what I use it for. But these functor test suite combinators, they aren't as useful as the rest of them. Good point though. Okay.
Any plans to add the traversable?
Be my guest. I don't know the laws for traversable, so I haven't, and I also mostly don't use it like that. So
I guess I would also ask Edward to check all this.
okay. Yeah, it would be nice to get some contributions from them. Cool. Let me try and turn this off.
So I don't know if you've shown those. Have you used it on a program of yours, and have you shown like the instances that are needed to test a real program and not an example? Sorry, I wasn't here for 15 minutes.
So, do I understand your question correctly? Which instances do I need for a real example?
Yes, exactly.
All right. So yeah, that's
in the real nitty-gritty, program where it does boring things mostly.
Here. These are the lines you need. These 3 lines. That's nothing is omitted here. Implementation is generated by generics. Implementation is generated by generics. Implementation is generated by default implementation. And then you need the generic instance here. So these 3 lines and this extra word there, that's all you need to get started.
Well, that's cool and all, but what if this is, what you're after is not, a general text, but you're only operating on the messages of this particular protocol? Then you can't generate it, right? You have to manually write the instances.
I think what he's after is some non-trivial validity notion.
Yes. So say my type can only hold values
that are
part of the IMAP protocol.
Okay.
It can't generate those automatically because there's no notion of that protocol.
Yes.
How would I go about implementing such a validity instance?
Aha. Okay. So that's okay. I can go through that if you'd like. The short answer is make sure your types are as constraining as possible, and then write the validity instance for the rest. So let me show you an example of a validity instance like that. I have to remember the right button. No, that's the wrong button. Does this work? All right. So let's say your message has to start with a T, right? Is that constraining enough for the example?
Yeah.
So deriving show eq generic. There's a bit of lag between that screen and this screen, so sometimes. So you need those. This should compile as is, I think. Nope. Because I need gsc.generics, and I need to import data.text. And I will also need same thing qualified. That works. Okay, and now I want to write this validity instance for it, right? So I will implement the validate function. And now I want to define that the text is valid and that it starts with a T. Right? So the way we do that, to make it forward compatible with the future, you do this validation object is a monoid. So first I say generic validate. So all the subparts are valid. And now I'm going to define the rest for myself. And the rest here will be declare the text starts with a T. Okay? And then I say d.unpack. If it's empty, then it's valid. If it starts with a t, then it's valid. If it starts with something else, then it's invalid. Text starts with a t. So you describe what it would look like if it's valid. And then it will give you a nice output that says this thing is violated. What went wrong here? Oh, right. Ah. That's better. No validity text because I need to import data validity text. Still nothing? What went wrong here? But I just imported the one for text. How does that work?
Just import the whole module.
What whole module? Like that?
Yeah.
That won't help.
Yeah, that won't help because I'm only importing an instance anyway. That makes no sense. Alright, let's leave this out for a moment because that's not the point of what you're asking. Alright, so now I can say validate or pretty validation, which will return an either. It's going to be wrong, and it will return a left. And I will say my message hello, which doesn't start with a t. And now I need to set overloaded strings. I got the left, and now I can say put string s. Voila, and you get nice output that says the text starts with a t. This invariant is violated because it's an h.
So the way it's generating it is it's going letter by letter. So it's generating one letter long text, checking that, and then checking each of the other letters, right?
So now we've only implemented validity. Now we haven't implemented the generators yet. So let's do that as well. Gen unchecked.
It's in the default generator.
It must be.
Right, we need to import that as well. This is so weird. Why does these don't exist for some reason?
If you have a version that's pinned, that's not the current one.
Yeah, maybe. So that's why I'm trying. It can't find these modules, but that makes no sense. Anyway, I don't know what went wrong, but so you can implement your own generators like that. Sorry, these are just the default ones. Now, if you want something faster, then check something unchecked and see if it's valid. What you can do is you can write gen valid equals add a t on at the front of a valid string, and then you want to pack it.
And this is super useful compared to what I'm doing right now. So right now I'm just throwing random strings and checking if they are valid, which takes a long time.
Exactly, and this is exactly the problem we had with paths as well. So if you look at genValidity path, that's for file paths, but they're from the typed file path package that we use. To generate a valid file path that's absolute, you just add a slash in front of an unchecked path and then check if it's valid.
Yeah.
So you still do the generate something and check if it's valid, but now the things that you're checking are more likely to already be valid, and that's already fast enough usually. And then you can do the same thing for directories, and they have to end with a slash. So you can complain that I'm using these ++ here and it's linear time. I don't care. This is about developer time, right? If this is ever too slow, we can still make it faster, but at the moment it's fine, right? So please forgive me if I don't want to engage in this mental masturbation of optimizing these things just yet. If we ever get to the point that everything works so well that we have to start caring about whether our test suite takes 60 seconds or 6 seconds, I'll be happy to engage in it. But at the moment, the problem is that there is no test suite. Instead of it's slow, too slow. You see the problem? Anyway, sorry, I'm not bitter, I promise.
So, is your work on Cardano open source?
I just complain about other people, so I don't write much for Cardano.
Okay.
In fact, I'm not allowed to write much for Cardano because otherwise I would be auditing myself and I would have an incentive not to find the problems in my own code, which is not a good idea, right?
Okay, so I was wondering whether you could show us some real-life examples of what you're doing for us.
No, that's confidential.
Yeah.
Hold on.
Last time I checked, Cardano published that audit report.
Can't comment too much on that. Long story. It's too long and complicated for me to figure out what I'm allowed to tell you at this moment for me to respond on that.
I found this auditing report online on the Cardano webpage.
Yes, so there are published reports,
I mean,
but that doesn't mean I can respond to every question. And I will probably also talk about these reports in an entirely different presentation, but that's not the point here. I can tell you that a lot of the things I have found to break into whichever project I was working on have been done thanks to this kind of property test, where I just throw in random garbage into someone's code and then I see whether it crashes. By the way, grep for to-do, that's also a great way to find to-do, fix me, this is broken, and then you can pick it.
One other question. Do you have any idea as how to generate valid source code in a programming language? Have you tackled such a problem?
I've not done it for a real programming language. I've done it for expression trees.
Does it start?
Yeah, if you can generate an arbitrary expression tree and then convert it to text that represents it, that's a good way to start, I think. Do you see what I mean? So don't try to generate a string that represents valid code. Generate a valid ADT and then convert it to a string.
Okay, how do you check for a valid ADT?
Well, it depends on what you mean by valid. That's the problem, right? So in C, you can probably get away with a lot of stuff, whereas in Haskell, it's quite annoying to make code that actually type checks, if you see what I mean.
Although it might actually be easier in Haskell if you start from top, so to speak, because you already have the constraints. Like you know what type goes in this part of the tree, right?
I've had problems with exactly this for my master thesis. I can tell you it's not as easy as you think it is.
Well, no, I'm not saying it's easy. It's just that in C you can very easily write a program that overwrites itself because it's harder in Haskell.
Yeah. So figuring out what.
There is some kind of generator of C code for filing C compilers. I don't remember the name right now, but I've read it's pretty advanced. Like it can generate. Like it's actually useful for testing compilers. So it means it doesn't just generate some garbage, but it generates some stuff.
I also know that the V8 team does this at Google. They do it in a rather primitive way, but they also generate a JavaScript for fuzzing to check whether their compilers work.
So to take it is right that your MSc was on fuzzing?
No. So the problem, so this is an entirely different topic that I can talk about for 7 hours as well. The point I was trying to make is that now we still have to figure out what it means for your code to be valid. So usually you write code and then you, in hindsight, you go, oh, I better test this. And then you write some tests and you go, I don't like this. And then you go do something else, right? The problem there is that you haven't thought about what it means for your code to be valid yet when you wrote the code. And that's perfectly natural. I don't want you to convince you that you should do that. I want to find a way so that you can still test your code, even if you haven't done that. So my master thesis was about looking at your code, pressing button, getting properties of your code. So press button, get properties. And I can actually see if I can show you a demo of that. My Control R. Oh, that doesn't work, does it? Oh no! That's stupid. When I press Control, it stops the recording. So let me just pause the recording, save it, and then I can show you. Right, so this is not recorded, but now I can do my sort. See if that works. Voila. So I have this little toy example of some sorting code. Right? I press one button, then I have properties of the code. So that you don't even have to come up with your test yourself anymore. You just press a button and you think like, oh, this is a property that I want, and you just copy paste it in your test suite, and you don't even have to think about the test you want to write anymore. That's the idea.
Very nice. Will I be able to track that down using Google or something? Like that?
Sure, but it's research, so it doesn't actually work. So we have a paper. And you can read that, but in practice it doesn't work because it's research, and if it wasn't my way, then I would have done it the other way around without a paper and actually working code. But that's not the case at the moment. So there are a lot of practical reasons why this doesn't work. None of them are theoretically fundamental problems. So I have been looking for funding to try and do this, and I have got investment interest, but the people that I was talking to that wanted to invest had no idea what I was doing, so I went to work somewhere else. So yeah, this is recent research, and it's quite fun. It's a lot more difficult than I thought it was going to be. And so one of the things I have to do is generate all possible programs with your code. And figuring out which functions you can actually compose is non-trivial. That's why I know exactly what Michal was talking about. Make sense? Anyway, that's another topic entirely.
Did you use types to find them? Or?
Yes, yes. And it's not just me that did. So the generating all the possible programs that can compose, that's not me who did that. That was the QuickSpec authors, which is what I was building upon, but I had to do for some heuristics that I'm using, I had to do this as well, and it's non-trivial.
So how is your work different from QuickSpec?
I'm
not familiar with it, but I've heard about it and hear about your stuff, so what's the difference?
So QuickSpec requires you to write a bunch of code. Like for this example of my sort, you would have to write about double the amount of code that you see here just to find the properties of this code. So it requires you to type, to compile, and to run, and then to look at the output. So no one's ever going to use it in that form. And it's exp space complete, the problem that they're trying to solve, which means that if you run this on a real code base, it will never finish. So the difference with my stuff is I build on top of them, and I invented this thing called signature inference, which allows you to figure out what you should be asking QuickSpec in order to get a response in a reasonable amount of time without having to write any code.
Okay.
That's why you can press button see output, and that's why it takes 4 seconds instead of long. So I gave up, so it was already not sound because it's random generation. I also gave up completeness, and I had an extra assumption which allowed me to make it constant time. So instead of finding all of the properties of all of your code, I only want the properties of the last function I wrote. So I only need to find the properties of one function and how they relate to the rest, which is a different assumption. And I gave up finding all of the properties. I only want the ones that it can find fast enough for me to use it.
Okay.
That's the idea. Anyway, that's a completely different topic.
Do you have any other software for testing besides EasySpec and Validity to recommend?
Give us a look.
You started advertising, so maybe we can learn more.
For testing. No, I just recommend you do it. I also gave some talks about testing in practice. That was a webinar, so there I explained how to use property testing to test database applications or web servers. So, like, how do you do it? What code do you write to do this in real life? I also gave 6 hours of lecture, also thanks to Michal, about testing for beginners. So, starting from scratch, you've never tested anything, what do you type? That's also a lecture you can find. Anything else I need to recommend? I don't think so.
And he think he's looking for some critique of existing packages. Like
You mean like critique of not testing enough, or critique of not being tested?
well of using the wrong stack to test, basically.
So if that's what you want to hear, then don't use JavaScript. I don't know.
You're on the safe
No,
side.
I'm using JavaScript, but you know, I have this secret sauce, which is basically I have validating compiler that generates by JavaScript, right?
Okay. So if you're looking for critique of Hedgehog and QuickCheck, then I'm writing a blog post at the moment, which will be on the FP Complete website at some point, about the differences and the similarities between QuickCheck and Hedgehog and why some things don't work, and like will be more of an explanation about that. I've thought about this long and hard, and I still can't figure all of it out. So it's normal if you think this is annoying or hard, right? That's completely normal.
How does performance of your library compare to QuickCheck or to Hedgehog?
I'm using QuickCheck generators, so
Okay.
it's equally fast there,
Mhm.
except we found that if your property test suite is slow, it's probably because your generators are slow. If your generators are slow, it's probably because you're generating unchecked things and checking if they're valid. So in that case, it's probably slower than QuickCheck in most cases, by trading off that you can actually use it for some cases that you couldn't use QuickCheck. So it's probably a bit slower, and it's something you can fix yourself by writing some of the instances yourself if you want to.
Do you do anything like trying to first hit the corner cases? I don't know, having a non-uniform distribution of the test data that would make sure that you always test for 0, for 1, for max end, and stuff like that?
Depends is the short answer. So for example, for doubles, we generate a valid value in most cases and an invalid value, which is only none and infinity for unchecked values. That's the only place where I do something special. For integers, we just use for most things we just use the QuickCheck generators, which means that for integers you will mostly generate small ones. For doubles, the same thing. For lists, you mostly generate small lists, including the empty ones, so that's definitely a corner case. So not particularly, but usually generating random stuff is already good enough to hit corner cases. I think the sir with the teal shirt wanted to say something earlier.
Yeah, I was gonna ask about that. You talked about testing database in APIs with spec, but you already found it. So.
Super. Oh, by the way, the slides for what I showed you today will be in the Validity repository because it's just a markdown file. It's a presentation backward.
Okay, what will happen if the generator cannot generate a valid data for a very long time? It will just continue to work until it... Okay.
Yeah, it will just stay looping. So that's why there is also a test suite combinator to test your generators being generated correctly.
Oh,
so
it is there.
Yeah, but, well, not in the case that you're looking for. The reason it's there is mostly to see if it finishes.
Okay.
And of course, if you override something yourself, you want to make sure it's still all valid, even if you don't generate all the things.
So QuickCheck has I think it has a limit basically on the number of unsuccessful iterations.
Okay.
Yes.
Not for generators, only if you do implications. So if you say something like for all x smaller than 3, then something else, and x is never smaller than 3, then it will stop at some point. But if you just have a generator that tries to generate something, then it will not stop there.
You have to the generator run for a couple of minutes.
Exactly, and then you have to shut down your stuff because your RAM is full and it starts thrashing. I had that before.
What about testing the monadic programs or event sourcing?
I've had to answer this question for my master's thesis as well. In theory, you can model impure programs by adding the universe to your input state. In practice, we don't do it. Does that answer your question?
But what about monads that aren't I/O, say a state monad?
Yeah, you can do that. Yeah, and I do. And there are separate. There is already a library for testing state machine applications with properties, but I've never had to use it. I will start to use it on exactly the project you're thinking of at some point, hopefully, but not yet.
So
Actually,
we
I'm not sure.
continue.
Yeah.
So I found recently that for complicated structures, it's not feasible to generate, like it's not easy to generate a valid instance, but it's feasible to start with something small, like an empty data structure, and build it up with small mutations.
Mm-hmm.
Then as I go along, I just check whether the state is valid
Yeah.
in between those.
Yeah.
I think Kerckhove has some support for that. I looked briefly at it, but it seemed too complicated. But have you had experience in doing this? Maybe some tooling around it?
So I've done this before. I've just written it manually. I've not done it with Hedgehog for reasons that I will describe in the blog post I was talking about. So I don't use any special tooling for this. But I do stuff like this every once in a while. For example, when generating blockchains, you sometimes have to just add stuff and then see if it's still valid, or otherwise try again. Cool. I stopped the recording already because I had to, for Control R reasons.
Sure.
But I have most of this presentation.